Okay, now we're going to look at solving quadratic functions. There's four main ways that we do this, but in this video we're only going to look at by factoring and by taking the square root. So, factoring. A factor is when you factor something, you rewrite it into multiplied form. So, for instance, factors of the number 8 would be 2 times 4. 8 has been factored into 2 times 4. Another factorization would be 2 times 2 times 2. This, for instance, is called the prime factorization of 8 because it's only prime numbers. Another factorization of 8 would be 8 times 1. It just means that rewriting something into multiplied form. So this is a subtraction. This is a difference going on. This is the difference of two terms. This is the sum of two terms, and this is the sum and differences of terms. We're going to factor these and rewrite them into multiplied form. Something times something. Why do we do that? Because when you have some things that are being multiplied, a times b equals to 0, if you think about this for just a minute, this will only ever be true when one of the numbers here is 0. This will be true when either a is equal to 0, this number is 0, or this number is 0. If you try to make two numbers multiply and equal 0, you cannot do it unless one of them is 0. This is known as the zero product property, and you learn that in intermediate algebra, and I'm reminding you of that because we're about to apply it here. Okay, so the first step to solving a quadratic function, ax squared plus bx plus c is 0, is to have a 0 on the right hand side. We will be doing this. What makes this quadratic as opposed to linear is this power right here. The highest power of any variable that we see is a 2. That's what a quadratic function is, and that's what we're going to be talking about. So to solve this, we will end up getting two answers. That's based on the fundamental theorem of algebra. That's why we get two answers here. A linear function, the highest power is 1. We get one answer when we solve it for something. We get one solution. That's how it goes. When you have a polynomial, whatever power that is, at the highest degree, that's how many solutions you'll get. So this is quadratic. We'll be getting two solutions. Right here, x squared minus 16. This, you learned in intermediate algebra, is something called the difference of squares. When you have something squared minus something squared, you can factor this. This will factor into x plus 4 times x minus 4. Then to finish solving this, I'll just set each factor equal to 0 and solve. This will only be true when this factor is 0 or when this factor equals to 0. So then I'll solve this and get x is equal to negative 4 or x is equal to positive 4. That is what the answers are to this. These answers, when you take an equation and set it equal to 0 and solve for these x's, these are called solutions, roots, zeros, and x-intercepts. That's what these guys are. Right here, let's solve this by factoring. Well, this does not fit into one of those nice little patterns. This is not difference of squares, but this is always allowed. If you can possibly factor out the greatest common factor, that counts as factoring. So when I look at these two, they both have x's in them. Let's factor out an x. That leaves me with 3x minus 4. Guess what? This has been factored. It is now this times this. This equation will be true when either this factor equals to 0 or when this factor equals to 0. I'm going to solve each of these for x. Well, this one is solved for x. That's one of our solutions right there, right? This one, add your 4, divide by 3. Is my second solution. These are the two solutions for this one. We solved him by factoring. All right, let's look at this guy. Is this difference of squares? Oh, this is not even in good shape. Do you see I've got a 20 over there? I do not have a special rule about the number 20, although it's a very fine number. We do have a special rule about 0. We need a 0 over there, so we need to subtract the 20. X squared plus x minus 20 is 0. Now we're going to solve. This is a trinomial. I'm going to show you how I like to solve trinomials. Look here. This is also a trinomial. 6x squared minus 25x plus 14 is 0. The 6 is the A, negative 25 is the B, and 14 is the C. I'm going to solve this one as well. I'm going to start with this one, which is a little bit more involved than this one. If you can do this one, then you can totally do something like this. All right. This is the AC method. You do not have to use the method that I use, but you do have to factor it correctly. I like this method because it is very effective and it makes sense to me. But if you are good at factoring, you can use your own method. There are great methods out there people use, but what happens a lot of times is some students think they know how to factor and they don't. So if you fall in that category, pick up this method. It's an easy one. All right, A in this case is 6. B is a negative 25, and C is 14. This is called the AC method, or the product sum method. Take A times C, and then you want to find two things that you can multiply together, two factors you can multiply together to get A times C that would add up to be B. So in this case, 6 times 14 is 84, and you want to find two things that you could add together to get B, which is negative 25. Now here's the deal. If I have to multiply two things together and to get it to be a positive, that only happens with a positive times a positive or a negative times a negative. In this case, it will be a negative times a negative because when I add them, I have to get negative 25. So I know both of these are going to be negative. Now, 84. I'm not familiar with 84, so what I do is I start to break it down. And here's one way I can break it down. I know that I even got 84 because I took 6 times 14. Now I'm going to break down the 6 and the 14. 6 could be 2 and 3, and 14 could be 7 times 2. And these are the numbers I have to play around with. What I want is two numbers I could add up to get negative 25. All right? Let me just look at this. 6, let me try 6 plus negative 6 times negative 14 would be 84, but negative 6 plus negative 14 is negative 20, and I need negative 25. So that didn't quite work. Let me try this. What about 3 times 7 is 21. What's left? 2 times 2. What's 2 times 2? 4. 21 plus 4 is 25. Oh, that's going to work right there. Let's do that. Let's say negative 21 times negative 4. Negative 21 times negative 4 is 84. Negative 21 plus negative 4 is negative 25. This is the winning combination. So what I do, after I found, this was my thinking work, okay? What I would do now is I'm going to rewrite this original problem, copy down the first term, copy down the last term. 6x squared plus 14. I'm not changing the polynomial's value, but I am rewriting the middle term into two terms. I'm splitting this up. Negative 25, I'm going to split this up into what I found this to be. Negative 21x minus 4x. This plus this is negative 25x. So I haven't changed the polynomial, but I've made it look different. Now I have 1, 2, 3, 4 terms. I'm going to group the first two together and group the second two together. And then I factor out the greatest common factor that I can find between these two terms. I can divide both of these by a 3 and an x. So I'm going to factor out a 3x from here. That leaves me with 2x minus 7. 2x minus 7. What can I pull out of here? I can pull out a 2, and if a negative falls right there, I have to take the negative. So let's factor out a negative 2 times negative 4x divided by a negative 2 would leave me with 2x. 14 divided by a negative 2 would leave me with negative 7. If you're ever like, did I do that right? Just multiply this back together to make sure you get the right things. These match. That's not coincidence. That is called good factoring. We did a good job factoring. So now, all we got to do is factor out the common factor of 2x minus 7. So what we're left with is 2x minus 7 times a 3x minus 2 equals 0. When will this equal to 0? When either this factor equals to 0 or this factor equals to 0. And this will be true when x is 7 over 2 if I add 7 and divide by 2. And this will be true when x is 2/3 if I add 2 and divide by 3. So here are my answers, and this is by factoring. So if you can do that one, you certainly can do this one by the exact same method. However, there's a shortcut you can take when the leading coefficient is 1, and it is. A is 1, B is 1, C is negative 20. A times C is negative 20. I want to find two things that I can add together to get a positive 1. So you think of the factors of 20, and if I got to multiply two things and get a negative, one has got to be positive and one's got to be negative. That's the only way that can happen. And the bigger number has to be positive because when I add them, I get a positive. You think of the factors of 20, after a while you'll come up with 5 and negative 4. 5 times negative 4 is negative 20. 5 minus 4 is 1, so that works fine. You can rewrite the middle term, you can group and solve. However, when the leading coefficient is 1, you can just go ahead and factor this guy straight into x plus 5, x minus 4. You cannot do that when the leading coefficient is not 1. But if it's 1, you can just go ahead and do that. Here, x is going to be negative 5, and x is going to be 4 when you set each factor equal to 0 and solve. Okay, that is by factoring. If you need more practice with that, I have other videos, and there's extra practice I can give you in the book. I can assign you some problems if you are rusty on factoring. The next method is by taking the square root. So let's do that. When can you use the method of factoring? Basically, when a polynomial is factorable, okay? Not all polynomials are factorable, but when they are factorable, you can solve by factoring, and so I will give you ones that are factorable when I ask you to solve by factoring. So I'm not going to be tricky. You'll be able to factor the ones that I give you when I say solve by factoring. When can you use the method of taking the square root? When it comes to you in a certain way. So this is how you solve by taking the square root. This is the second method, by taking the square root. That is if you can work this into the form something squared equals to something. That's when we can use this method. And so there's an x somewhere in this a right here. So how you would solve this, you would just take the square root of both sides. So let's just take the square root. The square root of this is equal to plus or minus the square root of that. So we get a is plus or minus the square root of b. This is the square root method, where a is some function of x, some term of x. And so we can use this method for this one. That's why I left him on the board. Could I rearrange this equation into something squared equals to something? Yeah, I sure can. I could rewrite this like this. X squared is equal to 16. If I add 16 to both sides, then I'm ready to go. Take the square root of both sides. The square root of x squared, so I'll just do this little extra step. The square root of x squared is just x, is equal to plus or minus the square root of 16 is equal to plus or minus 4. Remember that plus or minus is a convenient way of writing two separate statements. Here are the two separate statements. X is equal to 4 or x is equal to negative 4. That is what this statement right there says. So real quick, let's just do a few extra examples of taking the square root, solving by that method. What if they say solve, let's say they've got 3x squared minus 27 is 0. Let's solve this one. Let's solve this one. What if they give us something like, I don't see a good one on here, so I'll make up one. What if they give us 6 times x minus 2 squared is 36? What if they give us 1/2 x plus 4 squared is, I don't know what I want to say here. Let me see. I just don't know. Okay, 8. We'll say 8. Okay, let's do these real quick. Let's solve this. Let's see. Can we work this into something squared equals to something? Let's see. Let's move the 27 over by adding it. Let's see. Oh yeah, we could get x squared by itself, then we'd have something squared equals something. Divide both sides by 3. Now we're ready. Something squared equals something. Take the square root of both sides. So the square root of x squared is equal to plus or minus the square root of 9. We get that x is equal to plus or minus 3. X is 3. X is negative 3. All right, those are two answers right there. Let's do this one. 6 times x minus 2 squared is 36. This right here is the something squared. Right there. So we need to get it by itself by dividing both sides by 6. All right, that gives us x minus 2 squared is 6. We're ready. Take the square root of both sides. Square root of this plus or minus square root of that. The square root of something squared is just the something. So in this case, what comes out is x minus 2 is equal to plus or minus the square root of 6. Now to solve for x, we add 2 to both sides. So we get x is 2 plus or minus the square root of 6. One solution, 2 plus the square root of 6. The other solution, 2 minus the square root of 6. Okay, last example. 1/2 times x plus 4 squared is 8. We need to solve for x, and we want to try to use this method by taking the square root. We have to get our equation in something squared equals something form. Right here, this is the something squared. How will we get this by itself? Well, it's got this 1/2. Let's kill the fraction. This is like this divided by 2. Multiply both sides of this equation by 2 times 2 over 1 times 2. 2 over 1 times 1 over 2 is a 1. We're left with x plus 4 squared is 16. Let's take the square root of both sides. Okay, the square root of this is plus or minus the square root of this. The square root of something squared is just the something. Plus or minus the square root of 16 is 4. Solve for x by subtracting 4. X is negative 4 plus or minus 4. Here's my two solutions. Negative 4 plus 4, negative 4 minus 4. This gives me a 0. This gives me negative 8. Again, the answers that we get have names. They are called solutions, roots, x-intercepts, and zeros of a function. So keep that in mind, because that will become a big part of something that we see in just a little while.